Hello students, continuing from the previous lecture, let us derive Newton-Cotes quadrature formula here in this lecture. For that, in the very first step, I will take one I, capital I, which will consist, or I will be equals to some definite integration. Okay, when I am saying definite integration, I mean there will be upper limit, lower limit, one integrand and the element of differentiation. Here upper and lower limits are b and a. F of x is my integrand, dx is my element of integration. Okay, so I is equals to integration a to b f of x dx, where f of x takes the values y0, y1, y2 and so on up to yn. These n plus 1 values are there corresponding to the x values, which are x0, x1 and so on up to xn. As I already told you, I want the tabulated value to perform numerical integration to derive Newton-Cotes quadrature formula. So these are the tabulated values, x, y values corresponding to x values, n plus 1 y values corresponding to n plus 1 x values. Okay, now what we are going to do next, let us divide the interval a to b. A to b means lower limit to upper limit into n sub-intervals of width h, so that x0 is equals to a. You can see this, refer figure 8.1. So that x0 is equals to a, and last point x0 plus nh will be equals to b, and as we are taking h as a step size, same width, so x1 will be equals to x0 plus h, x2 will be equals to x0 plus 2h, x100 will be equals to x0 plus 100h and so on. In general, xn is equals to x0 plus nh, which will be the last point. Then the integration that we have considered in the very first step, I, will take the form I is equals to integration from x0 to x0 plus nh, because a is my x0 and b is my x0 plus nh. F of x dx will remain, which will be equals to, just listen here carefully what we are exactly doing, how this conversion is taking place. What we are doing, we are taking it as some h into integration 0 to n f of x0 plus rh dr. Why I am writing this? Can I write this first of all? Yes, I can always write this. How I can write this? By putting x is equals to, you can see on right, by putting this one, by putting x is equals to x0 plus rh. Can I write this? Yes, I can obviously write this, because x is equals to x0 plus rh. When I am writing, I can always write x in place of x. I can write x0 plus rh, which is there. So when you take a differential, dx will be equals to 0 plus h times dr. I am introducing that r there, okay, for some purpose. What is that purpose? It will be clear subsequently. Okay, so that will take the form h into integration 0 to n. Why x0 will be 0? Why x0 will be 0? Can anybody tell me? Because the converted integration is with respect to r, and when you write it x minus x0 upon h, it will be 0. So r will be equals to 0 to n. When you write x minus x0 upon h, okay, just you can see here what was there. There it was written integration from x0 to x0 plus nh f of x dx, and when I am substituting x is equals to x0 plus rh, therefore dx will be equals to, x0 is constant plus h is again constant, but yes, that is not constant. We are converting the integration from x coordinate to r coordinate. So dx will be equals to h dr. What about limits of integration? Okay, when x is equals to x0, when x is equals to x0, what will be r? rh will be equals to x0 minus x0 will be equals to 0. Therefore r will be equals to 0 when x is equals to x0. I hope it is clear. Let us take upper limit now. When x is equals to x0 plus nh, so therefore what this step will give? x naught plus nh is equals to x naught plus rh. Therefore, x naught plus nh minus x naught is equals to rh. X naught will get cancelled. Nh will be equals to rh. H will get cancelled. So r will be equals to n. So the limits will be, the new limits will be r is equals to 0 to r is equals to n. Let me write this. Let me write this converted integral as integration r is equals to 0 to n. R is equals to 0 to n f of x naught plus rh, and dx will be equals to h into dr. So I am writing dr here and I am taking h outside. So this is how the justification of that step is, this one. I hope it is clear now. Okay, so I will x naught to integration x naught plus nh fx dx will be converted to h into integration 0 to n f of x naught plus rh dr using this substitution. Okay, so this figure is very much important, and one more thing is very important. That thing is the knowledge of integration. Integration in the sense, what is the physical significance of integration? What is the physical significance of integration? We know definite integration signifies area under the curve, is it not? Yes, it is area under the curve. So when we are saying we are finding integration a to b fx dx, we are finding the area under the curve y is equals to f of x and x-axis bounded on the x-axis by x is equals to a and x is equals to b on the left and right respectively. So this figure is very much important. What we have done in this figure, we have taken that interval a to b into finite number of subintervals. We have divided that interval into n equal parts. You can read here. Let us divide the interval a to b in n subintervals of width h. Equal width में हमने उसको divide किया है इस तरीके से. Right? Now, coming back to that integration which we have just now verified, that integration is I is equals to h into integration 0 to n f of x naught plus rh dr. Okay, now you must be remembering that we have derived Newton forward interpolation formula in terms of p, where p is equals to x minus x naught upon h. Do you remember? Yes. Okay, so जो वहां पे p काम कर रहा था, p is equals to x minus x naught upon h, अगर आप यहाँ पे गौर से ऑब्जर्व करेंगे तो वो काम कर रहा है r. Small r I am talking about. The substitution is made in such a way that r is doing the work of p there. Just the notation is different, but meaning is same. Because when you take r, what is the value of r here in the substitution? R is equals to x minus x naught upon h. Okay. Yes, just remember this. Moving to the next step, h will be outside, integration 0 to n. Now that f of x naught plus rh is there, you know what is f of x naught plus rh? It is nothing but f of xp, is it not? F of x naught plus rh, it is simply f of x. We have seen interpolation techniques. Okay, you can see this next step. By Newton's forward interpolation formula, they have written this. Yes, I can always write that f of x naught plus rh. I can write y naught plus r into delta y naught plus r into r minus 1 upon 2 factorial into delta square y naught plus and so on. They have kept 6 terms here, and everything dr. In the square bracket, everything is there into dr. Okay, now what we will do next? Yes, we are coming to the end of this derivation. What we will do next? We will do integrating term by term. There are many terms here. In fact, there are infinite terms here. We have just written 6 only, and we have written dash dash dash. So we will integrate a term by term here. So what we will get? See, remember h is sitting outside the integration. H into integration 0 to n y naught dr. So it will be n into y naught, as simple as that. So nh. So when you will solve each and every term, when you will integrate each and every term, you will get this particular result. Nh integration x naught to x naught plus nh fx dx is equals to nh into bracket y naught plus n by 2 delta y naught plus n into 2n minus 3 upon 12 into delta square y naught plus n into n minus 2 whole square upon 24 into delta cube y naught plus something more in the bracket delta power 4 y naught upon 4 factorial and so on. Okay, okay, all right. Plus, no, something more is there. Plus something more into the bracket fifth order term plus something more in the bracket sixth order term and so on. So what is your task now? Your task is to verify this step. Integrating term by term वाली step आपको verify करनी है ऊपर की step से. मुश्किल नहीं है, बिल्कुल भी मुश्किल नहीं है. आसान सा इंटीग्रेशन हर एक स्टेप में आपको आएगा. वो इंटीग्रेशन आपको गलती किए बगैर सॉल्व करना है और ये इक्वेशन नंबर 1 आ रहा है, ये वेरीफाई करना है. ओके, आई होप इट इज क्लियर. This equation number 1 is known as Newton-Cotes quadrature formula. From this general formula, very important line coming up. This equation number 1 is called as Newton-Cotes quadrature formula. An important line is, important statement here is, from this general formula, we deduce the following important quadrature rules by taking n is equals to 1, 2, 3 and so on. For different values of for different integral values of n, we are getting the different formulas having different significances, having different advantages. Okay, so equation number 1 is a beautiful formula which is called as Newton-Cotes quadrature formula. In which sense it is beautiful? It is beautiful in the sense that it is giving birth to many formulas, including trapezoidal rule, including Simpson's 1/3 rule, including Simpson's 3/8 rule, including Weedle's rule. Okay, right. So let us see how the trapezoidal rule is coming. Putting n is equals to 1, what I will do for getting trapezoidal rule, equation number 1 is now the milestone equation for us. I will put n is equals to 1 in equation number 1 and taking the curve through x0, y0 and x1, y1 as a straight line. That is the polynomial of first order. So the differences of order higher than first become 0. You know, polynomial is a first order term. So first order term, if we take the first differences, other than first differences, everything will be 0. We have seen that in the difference table. Okay, so putting n is equals to, two things we have to take care here. We have to take n is equals to 1, that is one thing. The other thing is we have to take the curve through x0, y0 and x1, y1 as a straight line. Why the diagram was important? Let us go back to the diagram and let me tell you. Okay, so this is my first point, x0 and x1. x1 is nothing but x0 plus h. So what they are doing, they are approximating the curve y is equals to f of x between the points x0 to x0 plus h via a straight line. It is not always true that it will be a straight line. It may be a straight line, but they are approximating, something like secant method, if you can remember, something like secant method. We have every time we are doing it by, we are approximating it by straight line. So something like that. Okay, so when you draw a straight line at the point y0 and y1, or I should say y0 and y at x0 plus h, you will get a trapezium here. I am talking about this thing. You will get a trapezium here. Similarly, when you take x1 and x2 points, you will get y1 and y2 joined by a straight line. So another trapezium will be there. Another trapezium will be there between x2 and x3, x3 and x4, x4 and x5, xn minus 1 and xn. Okay, so like that, by approximating the curve between the 2 points which we have divided via a straight line will lead us to a trapezium, mini trapezium. That is why this rule is called as trapezoidal rule. Okay, so when you put n is equals to 1 and you take the curve through x0, y0 and x1, y1 as a straight line, that is the polynomial of first order. So the differences of order higher than 1 becomes 0. What we will get? It is just the matter of putting n is equal to 1 there and nothing more. So we will get, what we will get? Put n is equal to 1 in this big formula, integration x0 to x0 plus 1h. Is it not? Is equals to nh है, तो वहाँ पे आपको सिर्फ 1h हो जाएगा, like that. And only first order term आपको रखने हैं. So delta y0 के आगे कुछ नहीं आएगा. So y0 plus n by 2 into delta y0 plus 0 plus 0 plus 0 and so on 0. Okay, so we will get integration x naught to x naught plus h, f of x dx is equals to h into y naught plus half delta y naught, which will be equals to h by 2 into y naught plus y1. Delta कहाँ पे गया? Delta y naught. Delta y naught is equals to y1 minus y naught. So this will be equals to 2 y naught minus 1 times y naught. So 1 times y naught will be remaining. Okay. So this is h by 2 into, so basically average of y naught and y1 into h. You can remember it like that. Similarly, the previous one was between the points x0 and x1. Let us talk about x1 and x2 now. x1 means x0 plus h. x2 means x0 plus 2h. So integration x0 plus h to x0 plus 2h fx dx is equals to h into here y1 plus 1 by 2 into delta y1. So again getting rid of delta by substituting the difference formula there, we will get h by 2 into, or basically average of y1 and y2 into h, and so on and so on and so on. The general element can be written as integration from x0 plus n minus 1 into h to x0 plus nh. So second last and last वाले ट्रेपेजियम को, और फिर सेकंड लास्ट या लास्ट वाले दो नोड्स को भी अगर हम लोग स्ट्रेट लाइन से अप्रोक्सीमेट करते हैं तो वो आखिरी ट्रेपेजियम रहेगा, और उस ट्रेपेजियम का एरिया हमको निकालना है, मतलब ही हम लोगों को इंटीग्रेशन निकालना है, और वो आ रहा है एवरेज ऑफ yn माइनस 1 एंड yn इनटू द स्टेप साइज. सो ये तो हुआ पार्ट में, हर एक ट्रेपेजियम का हमने एरिया निकाल के रख दिया है, अभी सबको जोड़ना भी तो है. So adding this n integrals, we obtain integration x0 to x0 plus nh. Okay, left hand side में हम लोग देख सकते हैं there is a continuity. Integral 1 is ending on x0 plus h, integral 2 is starting from x0 plus h, and so on. So integration x0 to x0 plus nh will account for the total area under the curve y is equals to f of x, and it is given by h by 2 into whole into y naught plus yn. That means sum of first function value and last function value plus 2 times y1 y2 and so on up to yn minus 1. This is what the trapezoidal rule is. This is known as the trapezoidal rule. ध्यान में रखने के लिए बहुत आसान है. कैसे ध्यान में रखना है? It is half of or h by 2 into first value plus last value plus 2 times intermediate value. As simple as that. Okay, observation is the area, I have already told you this, but let us read it once again. The area of each strip of trapezium is found separately. Then the area under the curve and the ordinates at x0 and x0 plus nh is approximately equal to the sum of the areas of n trapeziums. So basically each first trapezium, second trapezium, 100 trapezium, 128 trapezium, 200 trapezium, सब trapeziums का एरिया निकाला है और उसको ज्वाइन किया है. ओके, ट्रेपेजियम्स का एरिया इंडिविजुअली निकाल के उसको ज्वाइन कर रहे हैं, इसलिए इस रूल का नाम है ट्रेपेजॉइडल रूल. नेक्स्ट फॉर्मूला इज सिम्पसन्स 1/3 रूल. फॉर सिम्पसन्स 1/3 रूल वी हैव टू डू अगेन टू थिंग्स. ओके, वी हैव टू पुट n is equals to 2 here, unlike in the previous case where we put n is equals to 1. So putting n is equals to 2 in Newton-Cotes formula and taking the curve through x0, y0, x1, y1 and x2, y2 as a parabola, that is a polynomial of second order, so that the differences of order higher than 2 vanishes. This fact you know. If you don't know, just go through the previous lecture notes, even before mid-semester. Okay, so putting n is equals to 2 and we are taking the curve through x0, y0, x1, y1 and x2, y2. Here three tuples are involved. Okay, three points are involved here. Okay, and we are taking the parabola through those 3 points. Okay, let us see. So they are talking about, let us go back to the figure, x0, x1 and x2. These 3 points which can see, they are saying that let us take n is equals to 2. Obviously when you are taking n is equals to 2, you are talking about 3 points. One is x0 itself, one is x1 and other one is x2. Is it not? So through these 3 points, they are saying that let us approximate the given curve by the means of a parabola, by the means of a second order curve. So when you join it by parabola, and when you put n is equals to 2 in this very legendary formula, equation number 1, which is Newton-Cotes quadrature formula, what you will get? You will get x0 to x0 plus 2h fx dx will be equals to 2 times h into this. You have to see. Okay, this I am not going to tell you, this you have to see. Very simple, nothing. Equation number 1 में आपको थोड़ा देखना है डाल के, n की वैल्यू 2 डाल के देखना है, और सेकेंड ऑर्डर के बाद वाले टर्म सारे वैनिश हो जाएंगे क्योंकि आप लोग सेकेंड ऑर्डर का डिफरेंस ले रहे हैं. सो यू कैन सी डेल्टा वाई नॉट इज ऑल्सो देयर, डेल्टा स्क्वायर वाई नॉट इज ऑल्सो देयर, बट फाइनली we are getting h by 3 into y naught plus 4 times y1 plus y2. I don't want deltas here, I want plain y's here. So, okay, so just check it. Similarly we will get दो डिफरेंस का स्टेप फिर से आ गया, x naught plus 2h to x naught plus 4h, fx dx will be h by 3. You can see the pattern here, right? Everything is multiplied by h by 3, h by 3 into y2 plus 4 times y3 plus y4. So 4 coefficient we are getting in middle, and so on. So x naught plus 2h to x naught plus 4h, x naught plus 4h to x naught plus 6h, x naught plus 98h plus x naught to x naught plus 100h, x naught plus 100h to x naught plus 102h, and so on. Finally, in general, x naught plus n minus 2h to x naught plus nh, and which will be given by h by 3 into yn minus 2 plus 4 times yn minus 1 plus yn. So क्या है पैटर्न यहाँ पे, h by 3 into yn minus 2. So you can see the lower limit of the integration, n by n minus 2 is there. So that will be the first term here on the right hand side, plus 4 times yn minus 1, the term next to that, and you can see yn, it is nothing but x naught plus nh. So the upper limit is there, where n being even, obviously. Okay, and where n being even, again we will add all those integrals. We have n even. After when we add all those integrals, we will get integration x naught to x naught plus nh, fx dx will be equals to h by 3 into y naught plus yn. That means sum of first value and last value plus 4 times sum of odd values, y1 plus y3 plus y5 plus y7 plus y9 plus and so on up to yn minus 1, plus 2 times the sum of even values, y2 plus y4 plus y6 plus y100 plus y120 plus y200 etc. plus yn minus 2. This is equation number 3, and this is known as Simpson's 1/3 rule, or it is sometimes it is also called as just Simpson's rule, and it is most commonly used. Okay, right. I hope the derivation part is clear. Similarly for Simpson's 3/8 rule, let us see the observation first before going to the Simpson's 3/8 rule. While applying equation number 3, the given interval must be divided into even number of subintervals since we find the area of two strips at a time. I hope this observation is clear. This observation is very much important. What they are saying? They are saying that while applying equation number 3 or while applying Simpson's 1/3 rule, the given interval must be divided into even number of equal subintervals since we find the area of two strips at a time. अगर मैंने कुछ ऐसा डिवीजन किया है या फिर मुझे कुछ ऐसा डाटा दिया है कि मेरे पास 9 वैल्यूज है, तो मैं सिम्पसन्स 1/3 रूल नहीं लगा पाऊंगा, क्योंकि वो इवन नंबर ऑफ इक्वल सब इंटरवल्स में उसका डिवीजन हुआ रहना चाहिए. ओके, नो, एंड 9 है तो मैं कर सकता हूँ बिकॉज वी आर टेकिंग x0 x1 एंड सो ऑन अप टू x8. सो हियर आई कैन डू, आई वांट n वैल्यू एज इवन वैल्यू. Okay, if n value is even, then I can apply this rule. But if n value is odd, suppose I have divided the interval into 7 subintervals, then I cannot do, because 7 means it is giving you the odd value. So I cannot apply Simpson's 1/3 rule. Okay, so this observation is very much important. Simpson's 3/8 rule. Putting n is equals to 3 in equation number 1, a similar drill is followed. Trapezoidal में हमने n is equals to 1 रखा, Simpson's 1/3 में n is equals to 2 रखा. Putting n is equals to 3 here in Simpson's 3/8 rule in Newton-Cotes quadrature formula and taking the curve xi yi I is equals to 0 1 2 3 as a polynomial of third order. पैटर्न मिल रहा है, पैटर्न चल रहा है. वहाँ पे फर्स्ट ऑर्डर कर्व था स्ट्रेट लाइन, उधर सेकंड ऑर्डर कर्व था पैराबोला, यहाँ पे थर्ड ऑर्डर कर्व रखना है. सो क्योंकि थर्ड ऑर्डर कर्व है, थर्ड differences above third order will get vanished, and we will get x0 to x0 plus 3h fx dx will be equals to some pattern will be there. What is that pattern? That pattern is every time you are getting 3 by 8 3 by 8 3 by 8 in every I should say sub integral. So 3 by 8, every term 3 by 8 is there, that is why it is called as 3/8 rule. Likewise in the previous 1/3 rule, you must have observed every time 1 by 3 1 by 3 1 by 3 is coming. So finally 1 by 3 is there in that equation number 3, basic big formula. Here we are getting 3 by 8. Similarly x0 plus 3h to x0 plus 5h, Here the jump of 3 things are there. Why? Because we are putting n is equal to 3. So first integration was from x0 to x0 plus 3h. So not 1, 2, 3. यहाँ पे 3, 4, 5. Okay. So x0 to x0 plus 3h to x0 plus 5h. fx dx will be equals to 3h by 8 into y3 plus 3 times y4 plus 3 times y5 plus y6 and so on. ये पैटर्न मिल रहा है हम लोगों को 1, 3, 3, 1 का. Adding all such expressions from x0 to x0 plus nh where n is the multiple of 3. जैसा पिछले इसमें n की शर्त थी कि वो even रहे, यहाँ पे शर्त है कि n मल्टीपल ऑफ 3 रहे. ओके, सिम्पसन्स 3/8 रूल में अगर n मल्टीपल ऑफ 3 है तो ही आप अप्लाई कर सकते हैं. तो आपका नेचुरल क्वेश्चन आना चाहिए कि सर ऐसे बहुत सारे नंबर्स है जो इवन भी है और मल्टीपल्स ऑफ 3 भी है. तो मेरा जवाब ये है कि उस एक पर्टिकुलर एग्जाम्पल को आप किसी भी मेथड से सॉल्व कर सकते हैं, सिम्पसन्स 1/3 से भी, सिम्पसन्स 3/8 से भी. जैसे 6, yes it is even number, it is also multiple of 3. Okay, so you can solve it by Simpson's 1/3 rule as well as Simpson's 3/8 rule. So integration x0 to x0 plus nh fx dx will be equals to 3h by 8 y0 plus yn plus 3 times y1 y2 y4 y5. So y3 is missing here. Just observe the pattern here. y4 plus y5, यहाँ पर y6 फिर missing है, plus yn minus 1. So plus 2 times y3 plus y6 plus and so on up to yn minus 3. So यहाँ पे 3 के मल्टीपल्स चलेंगे जो 2 के साथ है. जो 3 के साथ है वहाँ पे 3 के मल्टीपल्स छोड़ के सारे आ जाएंगे, 3 के मल्टीपल्स एंड फर्स्ट एंड लास्ट वैल्यू छोड़ के सारे आ जाएंगे. एंड पहले टर्म में तो है ही फर्स्ट और लास्ट वैल्यू का एडिशन. दिस इज नोन एज इक्वेशन नंबर 4 is known as Simpson's 3/8 rule. Again observation is there. While applying 4, the number of subintervals should be taken as multiple of 3. So अगर मेरे पास 9 है तो मैं Simpson's 3/8 rule अप्लाई करके न्यूमेरिकल इंटीग्रेशन निकालूंगा. Simpson's 1/3 rule वहाँ पे सजेस्टेबल नहीं है क्योंकि वो 9 is not a multiple of 2. As simple as that. Okay, last rule here is Weedle's rule. Putting n is equal to 6. 1 हो गया, 2 हो गया, 3 हो गया. अभी आपको एक्सपेक्ट होगा कि 4 होना चाहिए. No, 4 और 5 भी होगा कुछ रूल, we don't know, but in our syllabus we have Weedle's rule and it will be obtained by putting n is equal to 6 in the Newton-Cotes quadrature formula and neglecting all the differences above. We obtain what we obtain? Integration from x0 to x0 plus 6h. सीधा सीधा 6 का जंप है. ओके ओके, सो 6th ऑर्डर कर्व से इसको अप्रोक्सीमेट कर रहे हैं, देखते हैं क्या होता है. So it will be equals to 6 times h into this bracket. This you have to verify. I am keeping it as it is because in video lecture I cannot do much thing. So you have to take the responsibility and you have to verify that yes you are getting this. If we replace what they are saying, they are doing some adjustments here. If we replace 41 by 140 into 6th order term by 3 by 10 into 6th order term, the error will be made negligible. You can verify that 41 by 140 is coming out exactly equal to 3 by 10. Okay, you can use your calculator and see these values. So they are making some adjustment here for some purpose. What is that purpose? That purpose is to take 3 by 10 outside the bracket. Okay, if this replacement is done 41 by 140 by 3 by 10, then everything will be smooth inside that bracket and they will get integration x0 to x0 plus 6h fx dx will be equals to 3 by 10 into h into y0 plus 5 times y1 plus y2 plus 6 times y3 plus y4 plus 5 times y5 plus y6. You can see a beautiful pattern there. What is that pattern? 1 5 1 6 1 5 1. Is that clear? 3h by 10 into not to 6 तो चलते जाएंगे. The pattern is 1 5 1 6 1 5 1, right? Similarly, x0 plus 6h to x0 plus 12h fx dx will be equals to again 3h by 10 into 1 5 1 6 1 5 1. Starting from that 6 is repeated, y6 and here also y6. y6 plus y7 plus y8 y9 y10 y11 y12. So that 6 is repeated here. That will play important part. Many times students have the doubt कि सर वहाँ पे 6 repeat हो रहा है तो क्या उसको 2 times लेना है? देखते हैं क्या करना है. Adding all these integrals from x0 to x0 plus nh where n is multiple of 6, we get x0 to x0 plus nh fx dx will be equals to 3h by 10 y0 plus 5 times y1 plus y2 plus 6 times y3 plus y4 plus 5 times y5 plus yes 2 times y6. you have to take it, though it is cutted here, but आपको उसको लेना पड़ेगा. 2 times y6 plus 5 times y7 plus y8 plus and so on, and this is known as Weedle's rule. Observation is, while applying 6, the number of subintervals should be taken as multiple of 6, which was very obvious. Weedle's rule is generally more accurate than any of the others. Out of the Simpson's rule, out of 2 Simpson's rule, whether you can ask that, sir, whether 1/3 is good or 3/8 is good. They are saying that Simpson's 1/3 rule is better. Okay, and out of all the rules, Weedle's rule is better. Actually, we cannot comment like that, because it depends on the accuracy which we need. Sometimes trapezoidal rule may also do the work. Okay, no need of going for higher methods like Simpson's 1/3, Simpson's 3/8, Weedle's rule. Sometimes trapezoidal is also good. It is there. Okay, it is there in our syllabus. It has very much importance. Every rule is important. Okay, every rule is important. But yes, Tweedles rule, because it is approximating by a 6th order curve, it is going to be more accurate than any other. Okay, in the next class we will solve some examples related to this 4 rules. Okay, thank you so much.